Since the dawn of humanity, we've looked to the heavens and wondered, how old is the universe? How many stars are there in the sky? Are there other planets out there like our own? But in the last 25 years, there's been a revolution. All because of a machine called Hubble. Traveling in space, high above the distortions of our atmosphere, gives this giant telescope great power.
It's the size of a school bus. It's traveling at 17,000 miles an hour. It's 300 and something miles above your head. But in there is one of the most precise mirrors mankind has ever built.
Billions of times more sensitive than our own eyes, the space telescope has literally brought the universe to us, making more than 1 million observations. One legendary image is called the Pillars of Creation. It's a giant plume of gas and dust where stars are born. Our own sun probably formed in a place like this.
The whole region is something like 400 trillion miles. So it's massive, it's huge. But still within the context of our own Milky Way, it's just one little part.
Hubble has also captured pictures of places where stars die. These are planetary nebulae, remnants of expiring stars.
They look like artworks in the heavens. Each one of them is different, like snowflakes. And these are some of the most spectacular images that Hubble has produced.
Hubble has shown us that black holes are real. A giant one sits at the center of our galaxy, and nearly every other we know. It's discovered the age of the universe, and that there are more stars in the heavens than grains of sand on all the beaches and deserts of the world combined. Over the past 25 years, Hubble has told us a story of creation, destruction, and of vast new mysteries that beckon our curiosity. But putting it in space long seemed an impossible dream, even to those who took on the challenge.
I started out in optical astronomy and spectroscopy. But as a woman in my generation, I could not get tenure at a research institution. In 1959, when NASA was formed, one of the men there asked me if I knew anyone who would like to set up a program in space astronomy. And I decided that the idea of influencing astronomy for 50 years was just more than I could resist, and so I took the job.
Astronomer Nancy Roman is known as the mother of the Hubble. She worked on its design and development for nearly 25 years.
If I brought anything to it, it was perseverance and belief that it was possible.
The idea of a space telescope was first seriously proposed in 1946 by Princeton scientist Lyman Spitzer. He was the scientific visionary, and Roman was the force that pushed this vision forward, decades before the technology was up to the task. Even into the mid-60s, just getting a rocket safely into space was a challenge.
There were a lot of failures. We were babies learning how to walk. And we didn't always succeed. Babies fall down, and we did too.
But however far-fetched at the time, the lure of getting a telescope above the distortion of the Earth's atmosphere was strong. The major challenge facing astronomers was the twinkle of the stars.
Twinkling stars are an inspiring source of poetry, but in terms of observing stars, it's not very good.
If you can imagine you're swimming on the bottom of the swimming pool and you look up and you kind of see the distortion, just like a funhouse mirror. That's what it's like to study stars from the surface of the Earth. The atmosphere is just like that water in the pool. It sloshes around and moves and distorts the image. But when you come up out of the water, everything's clear. That's exactly what happens when a telescope gets above the atmosphere. In the pristine vacuum of space, light can travel for billions of light years, undisturbed.
The atmosphere not only distorts light, it prevents some from reaching the ground at all.
So for those reasons, astronomers for a long time were eager to get something outside. And so I got a committee together, and that was the beginning of the Hubble.
The Space Telescope was named for Edwin Hubble, the great astronomer who did much of his pioneering work in the 1920s at Mount Wilson Observatory in California. In those days, our own galaxy, the Milky Way, was considered the entirety of the universe. Nearly everyone, even Einstein, believed the universe had existed forever in its present state, that it was eternal and unchanging. But Hubble would prove them all wrong. He began by figuring out how far away the stars he was seeing actually were.
At the time of Edwin Hubble, it was hard to measure distances. It still is, even today.
It's difficult to know if a star appears bright because it is actually bright or simply because it is close to us. So Hubble searched for a rare type of star called a Cepheid variable. Cepheids pulse at a known brightness, so by measuring the amount of light he could see, he could calculate how far away the star actually was. In October 1923, Hubble found a Cepheid in a gaseous cluster of stars then called the Andromeda Nebula. It yielded a shocking discovery.
And when he actually did the calculations, he discovered Andromeda was roughly 1 million light years away from us, which was outside our galaxy.
Andromeda was its own galaxy.
Oh, there are other galaxies out there, and we're just one of them.
For the first time in history, there was evidence that our universe stretched far beyond the Milky Way.
But then what he did was, we measured the speed of a whole bunch of these galaxies.
Edwin Hubble measured speed by looking at the light the galaxies emitted. He knew if the galaxy was moving toward him, the waves would shorten and shift to the blue part of the spectrum. If it was moving away, the waves would lengthen and shift to the red.
Every distant galaxy Hubble looked at, he saw the light from it being redshifted, which meant everything is moving away from everything else.
And he found the further away they were, the faster they were going.
In fact, the universe itself was expanding, stretching the light from the galaxies. Edwin Hubble had changed our understanding of the cosmos forever.
The whole universe was clearly expanding. And so this was the discovery of the expansion of the universe, which Einstein said, well, that's crazy, right?
The discovery of the expansion of the universe, of course, was a very strong piece of evidence for a beginning. If everything is now expanding, you can run this backwards and see that everything should have started from a certain point or singularity, what we today call a Big Bang.
That was pretty radical and mind-blowing stuff back in the 20s and 30s, and some people today even find it mind-blowing.
Hubble's discovery opened up the modern era of astronomy and raised huge questions, like how old is the universe? But astronomers couldn't see clearly and deeply enough into the cosmos. So the mystery would endure for decades.
Determining the age of the universe was definitely one of the key goals of the launch of the Hubble Space Telescope.
Astronomers used to have fist fights where the universe was 10 billion years or 20 billion years old until we launched the Hubble Space Telescope.
But first, they would have to build it.
I realized that my job at NASA, to a large extent, was salesmanship. And it was a particular problem with Congress.
We can cut the space program sharply. The Congress has already cut that $400 million. I think we can cut it $1 billion, and we should cut it $1 billion.
Proxmire was quite famous senator of picking out projects that he thought were stupid.
We have a war going on in Vietnam.
And he asked NASA why the American taxpayer should pay for something like the Hubble. And I came up with the answer that for the cost of a night at the movies, every American would have 15 years of exciting discovery.
Finally, after more than a decade, the plans were approved in 1977. Hubble's power would come from an 8-foot-wide mirror. It would gather light from across the universe. To magnify the sky and see tiny details, it would need a long distance to focus the light and give a clear image. But a space telescope needs to be compact, so Hubble would use a second mirror to further magnify the light and focus it onto the cameras. For it to work, the mirrors would have to be perfect.
Hubble was the most precise optical mirror ever made.
No place along its surface could it deviate from a perfect curve by more than a millionth of an inch.
An optics company, Perkin-Elmer, was chosen to do the work, in part because it had already made mirrors for spy satellites.
They told NASA, we know how to do this, and this technology is proprietary. We are not going to let you come in and watch what we are doing. So NASA got a rather limited view of what was going on in that little group.
They had very, very precise instruments that they designed just for polishing this mirror. They had to work at night so that the vibration of cars in the parking lot wouldn't cause problems with the polishing equipment. They had to isolate it and float it on a table so any vibrations from the building wouldn't come in. And this program was over budget, behind schedule. They were desperate to get the telescope built and flown.
Perkin-Elmer's own measurements showed discrepancies in the surface of the mirror, but this was never passed on to NASA. The telescope was declared ready for launch, a disaster waiting to happen.
The hopes and dreams of the world's astronomers were with us that day at Cape Canaveral.
Go ahead.
The last time astronomers leapt a factor of 10 in observing capability was when Galileo in 1610, instead of using his eye, put the telescope in front of his eye.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
All increases in capability after Galileo were incremental. They weren't leaps of a factor of 10 until Hubble.
Mission Control, Houston.
Roger, roll, Discovery.
We thought, let's go, we're off to the races. Little did we know the time bomb that was ticking. Little did we know.